In this video, we are going to talk about how to determine if an acid or a base is strong or weak and what that means for the stability of the reactions that we have. So, we know that some acids are more reactive than others. And what we call acids that are more reactive or less stable, we call those strong acids. Acids that are more weak, we call them weaker acids. They are less reactive and maybe more stable. We'll see some examples and lists of this in class. And we can determine how strong an acid is by looking at the stability of the conjugate base of that acid. So what we'll see is that stronger acids have a more stable conjugate base. Weaker acids have a less stable conjugate base. That's a lot of information, so let's look at an example. Here is an example reaction. Here is our acid, okay? And it corresponds to this conjugate base over here. So what we want to do is see, let's compare the stability of the conjugate base to the stability of this base. And by doing so, we're going to see if our acid here, or our conjugate acid here, is the stronger acid. Okay, so we're trying to decide, is the acid more strong or the conjugate acid strong? And we look at their conjugate bases and the base to compare that. So let's pull that together here. Here is the base and the conjugate base. Which of those is more stable? Well, we can look at all of these factors that we already know, and we can say that charge, they both have a charge, and since they are both oxygens, we can't compare on charge, and they're both minus charges, so that doesn't help us very much. Same with atom size, they're both oxygens, so the atom that we're looking at for stability, they're the same. Same for electronegativity, they're both oxygens, so they have the same electronegativity, so we can't use that as a factor of stability either. However, we can use resonance. We know that this conjugate base has resonance, making it more stable. And we expect that you would recognize that and see that there's resonance opportunities that would make this conjugate base the more stable species compared to these two. So taking what we know about that, and here's a list of the factors we already know: charge, atom size, electronegativity, resonance, inductive effect. You can ignore the hybridization for now. This is just a summary of the information we already know about how to predict stability. So that might be helpful for you. So here is our reaction again, and we just determined that this conjugate base is the more stable base compared to this one. And that is relative to each other. We're comparing between the two, and we see that one is more stable than the other, okay? And the conjugate base that is more stable corresponds to the stronger acid. And by that I mean this is the conjugate base of this acid. So that is the stronger acid, making the acid on the other side the weaker acid. So why is that true? Well, let's think about where the proton is most stable. Here's the proton here, and here's that same proton on the other side. If the proton is more stable on our conjugate acid, or the weaker acid, it's less likely that this reaction will proceed in reverse, right? The lone pair from our conjugate base could grab that proton and we would go right back to where we came from. But it doesn't do that as much as you would expect, because this side, the right-hand side, is pretty stable. This lone pair is pretty stable on this conjugate base, and the proton is more stable on our acid. And so when we are conjugate acid, and so when we're thinking about why we need to look at the stability of the conjugate base, we're looking at how likely is it that the reaction will go back the other direction. Or where is the proton more stable? Is the proton more stable in the left-hand side in the presence of this base? Or is the proton more stable on the left-hand side in the presence of this base? Okay, and it's not just relative to the base. We can see that how tightly a proton is being held on the acid has to do, in a lot of ways, with the structure of our acid. And so we're going to talk more about that. Strong acids versus weak acids will have very specific structures that make them strong acids. And then we can predict which acid is stronger in a reaction by looking at our conjugate bases.